Hi everyone. Let's take a look at the following physics example. Train A has a length of 1 kilometer and travels at 50 meters per second. Train B has a length of zero point 0.5 kilometers and starts just as the rear of train A passes the front of train B. Train B has an acceleration of 3 meters per second square and a maximum speed of 60 meters per second. When does B pass A? That is, when does the rear of B pass the front of A? How far has A traveled in this time? So step one, I'm going to draw a diagram. And instead of reverting back to the GRASS approach, I'm just going to give you the most important section, which is the AS, how to analyze and how to solve this. So again, in the beginning of this diagram, I'm drawing train B. And this is the front of train B. And relative to train A, the front is going to be right there. Now, it's important that when you think about the metric, that you express it in the same units. So, for example, instead of saying 0.5 kilometers, train B will have a length of 500 meters. Likewise, if you think about train A, instead of saying 1 kilometer, it's going to be 1,000 meters. Now, the first step is you want to figure out how much time it takes for train B to go from 0 all the way to 60 meters per second. So again, notice in this part of the diagram, time is exactly 0. So you go back and you look at the following formula. Vf equals the Vi plus At. Now the final velocity is going to be 60 meters per second. That's going to be the maximum speed. And of course, train B starts from rest, so that's going to be 0. And the acceleration is going to be 3 meters per second times time. So without a calculator, if you do a little bit of mental math, 60 divided by 3 will give exactly 20 seconds in this case. So the next question becomes, how far did train A travel in 20 seconds? How far did train B travel in 20 seconds? So if I continue here, I can look at train B. Let's write down delta dB. And this is VIT plus half AT squared. And again, recognizing that train B started from rest, that's going to be 0. So this is going to be half times 3 times 20 squared. And again, you can take the calculator, you can do a little bit of mental math. That's going to be 1.5 times 400, which will be 600 meters. Now, really important you keep track of that. What does that really mean? Relatively speaking, again, it's not a perfect diagram, but the train is going to be here now, meaning the front end is going to be 600 meters, which means this gap right here will be 100 meters. And this measurement will be 500 meters, meaning you're advancing 600 meters. Now, if you think about the distance for train A, remember, train A is moving at constant velocity. So you could write down VIT plus half AT squared, but really the ultimate equation is going to be delta A equals to VIT because there's no acceleration. So that second part becomes 0. And again, since velocity is going to be 50 meters per second, that's going to be 50 times 20 seconds, which is 1 kilometer, or we'll put it back into the same metric, 1,000 meters. So train A has traveled another 1,000 meters. So notice the scale on this diagram, right? It's just another 1,000 meters forward. Now here's the gap, and here's the most important part. Again, the diagram is not drawn to scale, but let's say they meet somewhere here. Now the concept goes as follows. If you really think about the distance, D is what you're looking for because they're asking you how far has A traveled at this time. And D is basically the measurement from this point all the way to this point. So if you think about the bottom part now, the question becomes, well, this is going to be D plus what? Meaning there's this distance, which we know is going to be delta D, but we also know the length of train B is going to be 500 meters. We also know this gap here, again, be mindful of this gap, right? This is 1,000 meters. And this other gap is 400 meters. I hope you're with me, right? This is 400 meters because This is 100 plus 500 plus 400, which will give you the 1,000 meters at the top, plus another 1,000 meters, plus another 500 meters. So this means if you look at the gap at the bottom, that is exactly D plus 1,900 meters. And that is the distance from, let me go back, from the beginning here all the way to the end here, right? That's kind of the comparison you're making. So what that means is if you write down the next equation on the left-hand side, if you think about train A, again, remember, train A is moving at constant velocity. So even though you could say D equals to VI T plus half AT squared, really, it's just going to be D equal to, again, it's moving at 50 meters per second times time, because this is going to be 0. And I'm going to put a box around this. Now, if you think about train B, be mindful. Train B, it's also now moving at its maximum velocity. So even though you could start with this kinematic equation, VI T plus half AT squared, again, this becomes 0. So what that means is the maximum speed now is going to be 60, again, times time. But remember, this is now D plus 1,900, right? So if I highlight this for you in a different color, this entire distance is going to be D plus 1,900 meters. Whereas for train A, you're looking at D, just like that. And now the hard part is over because you can solve for the following, right? I can line them up and I write down D underneath. And now if I subtract them, 1900 equals to 10 times T, which means time is going to be 190 seconds. Now remember, you want to find the total time, and we already took 20 seconds from above here. So the total time here, if you think about it, again, is the 20 seconds that we solve plus the 190. So it's 190 plus 20, which is 210 seconds. And that's exactly the answer from the answer key, 210 seconds. Now, if I go back and I want to find the corresponding displacement, that's going to be 50 times 210. Again, you can put the metrics back in. This is exactly 10,500 meters or 10.5 kilometers. So again, this is the second answer, which is in agreement with the answer key right here. If you find this video meaningful and it's adding value to your physics life, please comment, like, share, and subscribe. I hope this makes sense.